Hello guys, welcome back to the course. In this video, we are going to learn about the basic fundamentals of geospatial analysis. For those of you who are already familiar with this topic, feel free to skip this video. However, if you're new and you want to learn more about geospatial analysis, make sure that you pay very close attention to this video. Firstly, you might be wondering, what is geospatial analysis? Let me explain. Geospatial analysis is the use of geographic information system to examine, interpret, and derive insights from spatial data, enabling the understanding of spatial relationship, patterns, and trends for informed decision-making across various disciplines. Okay, so now let's talk about geospatial analysis use cases. The first use case is urban planning and transportation planning. You can use geospatial analysis to map population density and land use pattern to inform city planning decisions such as zoning regulations and infrastructure development. You can also evaluate traffic congestion, optimizing public transportation routes, and planning infrastructure upgrades to improve mobility and reduce environmental impact. The second use case is supply chain optimizations. You can analyze distribution networks and warehouse locations to optimize supply chain logistics and reduce transportation costs. The third use case is public health planning. You can analyze spatial patterns of health outcomes, environmental exposures, and access to healthcare services to identify health disparities and inform public health interventions such as disease surveillance and healthcare resource allocations. The fourth use case is natural resources management. You can use geospatial analysis to assess biodiversity, habitat fragmentations, and deforestation patterns to guide conservation efforts and sustainable land management practices. And the fifth use case is energy infrastructure planning. You can analyze terrain, proximity to resources, and environmental factors to optimize the locations of renewable energy installations such as wind farms and solar arrays. Okay, so now let's talk about technical challenges and limitations in geographic information system. The first one is dealing with low quality data and large data volume. So low quality geospatial data can significantly impact the accuracy of the analysis. Inaccuracies, errors, and inconsistencies in the data may arise from limitations in data collection methods, sensor resolutions, and data processing techniques. These issues can lead to uncertainty in the analysis result, potentially resulting in misleading conclusion and incorrect decision making. In addition to that, geospatial datasets, especially high-resolution imagery data, can be large and require substantial computational resources and processing time for analysis, posing challenges for scalability and real-time applications. Okay, now let's talk about the second challenge. Georeferencing errors in spatial datasets and geocoding inaccuracies in address-based data can result in misalignment and positional errors, affecting the reliability and validity of spatial analysis outcomes. And the third challenge is spatial resolution constraint. So geographic information system datasets may have limitations in spatial resolutions, impacting the level of detail that can be represented and analyzed, particularly for fine-scale features and small geographic areas. So sometimes when you are trying to zoom the map, the resolution is kind of limited. At certain point, you cannot zoom it anymore. Okay, now let's move on to the next part. I'm going to explain geospatial analysis workflow. I'm going to explain the process using mind map. So here is the mind map, guys. The process is consisted of 4 main steps. The first step is data collections. In this step, we are going to gather relevant geospatial data from various sources. Regarding the data sources, the data can be obtained from satellite surveys and sensors. For your information, in our projects, we are going to download the geospatial datasets from Google and Environmental Protection Agency website. Let's talk about data formats. So the data formats can be shapefiles, GeoJSONs, KML, CSV, or Excels. Most of the data that we are going to use are in CSV format, but there is one data that is in GeoJSON format. Okay, now let's talk about data repositories. So the data can be obtained from repositories like Google Earth Engine, OpenStreetMap, etc. Okay, now let's move on to the second step, pre-processing and cleaning. In this step, we are going to prepare and clean the data. There are a few things that you are going to do. The first one is data transformations. You are going to convert data into a uniform format for consistency. The second thing that you're going to do is to do noise removal. You're going to eliminate errors and inconsistencies. And lastly, you're going to do georeferencing. You're going to align data with geographic coordinates. Okay, now let's move on to the third step, exploratory data analysis. In this step, you are going to perform initial investigations to understand the underlying patterns, trends, and relationship within the geospatial data. So there are a few things that you're going to do. The first one is to perform descriptive statistics. So you are going to summarize main features of data using statistics. The second thing that you're going to do is visualizations. You're going to generate maps and plots to visualize spatial data. For the visualizations, we are going to use two Python libraries. The first one is volume and the second one is ipyleaflet. And the third thing that you are going to do is pattern identification. So you are going to identify spatial relationship and trends. Okay, now let's move on to the fourth step, spatial analysis modeling. In this step, you are going to conduct advanced spatial analysis to gain valuable insight from the data. You're going to do spatial interpolations. So you're going to estimate unknown values based on known data points. You're going to perform geostatistics. So in this case, you're going to apply statistical techniques to spatial data. And lastly, you're going to perform spatial regressions. So you're going to analyze relationship between spatial variables. Alright guys, so that's geospatial analysis workflow. Hopefully this explanation helps you to understand. I think that's it. That's all you need to know. I'll see you guys in the next video. Bye.